I'm going to go back a little bit and go through a little bit of the history and who Markforged serves, and we'll talk about the whole printer lineup, which is now slightly different from what some of you may be used to from knowing Markforged in recent history. So who are we? Markforged is here to empower engineers, designers, innovators, and inventors to really remove all barriers between their design intent and final parts, strong, beautiful parts with as high quality as you can get from a 3D printer. Our goal is efficiency, ease of use as well. We were founded as a company in 2013 and launched the first Mark I product in 2015, and then the Mark II launched early this year in 2016, and now we've got a whole new lineup of products that we'll go through. Our goal is to be accessible to all, and with the Onyx series of printers, we are getting more accessible to folks with a different, different entry price points than we've had before in the past. We've revolutionized materials in 3D printing by introducing continuous carbon fiber, printing with other continuous fibers, and now we're working within Shop's carbon fiber and some other interesting materials that you'll hear about throughout the presentation. Our headquarters are here in Cambridge, Massachusetts, where we're all sitting today. However, we have hundreds of value-added resellers working worldwide in over 50 countries in all regions of the world who support customers locally. We're venture capital funded. We've had a Series B round with some of the best Silicon Valley and East Coast venture capital that are supporting our company. So that's a little bit about Markforged. We've received some recent recognition as well from Al Dean, who's the editor-in-chief of Develop 3D magazine. We've been on the Discovery Channel here in the U.S. We've had some interesting, articles and stories about our Mark-X when we introduced that 2 months ago. And we do really take seriously satisfaction of customers and do hope that all of our customers are, 5 stars. And if not, we've got a support organization to make sure everybody is super successful with our printers. One other interesting thing to note is the Mark II printer has been nominated to TechCrunch's Crunchy Awards for 2017 in Hardware of the Year product. So we're, hoping to see a win there, but otherwise it's great just to be nominated among some other, really interesting products and hardware. So that's a little bit about us recently. Our customers are now worldwide, so we do support all regions of the world, and we have recently launched in Japan and are quite happy about supporting that country as well. So customers include companies across aerospace, automotive, government and defense, consumer products, medical. We're in a lot of advanced sports and athletic equipment as well with the carbon fiber materials, as well as in a lot of academic institutions. And some of our customers are in large industrial machinery as well. So let's talk about that a little bit in future slides. Our parts are everywhere. We have quite a few customers using Markforged printers for production tooling and fixtures, and that's one of the areas where we've really seen a lot of growth and a lot of interest because of the materials, the strength, the properties, and ease of printing custom tools and fixtures within a production environment. We're also in end-use parts where the onyx material particularly has a look and feel that can be used in a product that's customer facing, and the properties of 3D printed carbon fiber with continuous fiber for added strength. So we're seeing our parts more and more going into final end use. We are in functional prototyping as well, where strength and precision and dimensions are critically important for applications in that area. We've got quite a few drones that have been printed on our printers, as well as just general other aerospace parts, and drones in particular, the lightweight of the carbon fiber, the ability to print a continuous body drone on our Mark X large size printer has been very interesting to people in that industry. Automotive, performance, sports, and racing. Right now, if you do have a chance to come visit our offices here in Cambridge, you'll see Ducati motorcycles that we have here, and we're actually replacing many of the parts. These are racing performance motorcycles. We're able to replace parts with such as the brake levers and other pieces on the motorcycle with carbon fiber printed parts, and they work. They're strong enough, and they make the motorcycle actually lighter weight. So this is happening across various customers and other folks who are using us in performance sports. And then prosthetics and orthotics, especially lower limb prosthetics, are something else where customers are using our printers for the ability to handle strength and weight needed for lower limbs is kind of unique to our printers. So just a few applications of Markforged printing, and I'll turn it over to John to go through a couple of end-use applications.
Hi, everybody. Nice to have you here today. So if we're setting out at the end of the day, when you're making a 3D printer, the real product that matters to the customer is the part that comes off of that printer. And if what we're doing here is targeting being able to actually use these parts as opposed to just sort of cosmetic prototyping with them, then those parts have to have some characteristics that we put a lot of time and effort into. Those are shown at the bottom of this slide. The parts need to be strong, and we'll get into some more detail there. They need to have really nice surface finish, and they have to have really good quality control. They need to be the right size for the application, dimensionally accurate, and repeatable, so that, and in this particular picture, you can see some grippers on the end of a robot arm that are used to pick up a valve coupling. They have to print 3 of these with a high degree of accuracy to use them in their manufacturing applications, so quality control is also critically important. And so we'll step through some of the ways we achieve these sort of goals. If you're not super familiar with our printers, they have 2 main components of material. The first is what we call the plastic side. The plastic side, our base material, we call onyx. It's a nylon with embedded microcarbon fiber. And it's sort of a unique material that we've developed in-house. It's tougher, stiffer, and more heat tolerant, and more stable than other 3D printing plastics. These characteristics mean that it warps less when you print it. It tends to stay more dimensionally accurate to what you intended. It's easier to print with, and it's about twice as strong. You can see it here plotted against just the nylon without the carbon fiber, or a ABS, which you may be familiar with as other 3D printers print ABS. And so on the plastic side, we will print onyx or nylon version without the chopped carbon fiber. And that's where you get sort of the cosmetic surface finish of your part, and the basis for what we do in terms of reinforcing it. And this is where we get really unique, the ability to wind a strand of continuous fiber through each layer of your part to make it stronger. You can see down here at the bottom right, this is a zoomed out view of the strength of the materials. Onyx is now reasonably far down the chart as you start to reinforce your parts with some of the other materials we have to reinforce them with, Kevlar, fiberglass, high strength, high temperature fiberglass, and then carbon fiber where you actually get strength that's stronger than aircraft grade aluminum. So that's our sort of unique value proposition, is that we can print a part that is dimensionally accurate and stronger than metal in many cases, in at least 2.5 axes. So you can start to use these parts in end applications that have some strength requirements or even some weight requirements. And just to give you an idea of the strength of the carbon fiber, these are a couple of videos. I don't think we're going to play them here, but they'll be linked to you so you can check them out on YouTube afterwards. On the left-hand side, we printed a chain link using continuous carbon fiber to reinforce it. And the pull test broke at 22,000 pounds. To put that in perspective for you, that's approximately the weight of a school bus. So now you have a printer that can print a part that could pick up a school bus. And that's different than anything that's been in the market before. And you can start to think about all the ways you can use these parts in some of those applications that Cynthia described. And then here on the right is an interesting video when we were on the Discovery Channel. Cynthia, do you want to talk a little bit about that?
Sure thing. This was featured on the Discovery Channel. It's on YouTube and linked here so you can watch it. They took a hammer to one of our parts printed from the Mark II with carbon fiber and tried to smash it and spent several minutes just banging at the part and nothing happened to it. So it's a nice visual just showing actually what happens when you try to break one of our parts. So those are kind of fun videos we will share with you after the today's webcast.
Okay, so let's take a look at our product portfolio as it stands today. And if you're familiar with our portfolio from the past, we've made some changes in recent history. You know, we have a pretty robust lineup that goes that is kind of differentiated based on strength and types of materials that the products can print. On the entry-level side, we have the Onyx One. We'll talk a little bit more about that, but that's a printer that just prints the Onyx plastic side material. Its build volume is 320 by 132 by 154 millimeters, and that's an incredibly affordable printer. You know, it steps up into the Onyx Pro, where you start to be able to reinforce the Onyx with continuous fiberglass. That has the same build volume as the Onyx One. And then the Mark II, where you start to get all of your continuous fiber reinforcements. The Mark II is also capable of printing just the base nylon if you want nylon without the chopped carbon fiber added to it. And then finally at the top of the line, we have the Mark X. The Mark X is where you get your Onyx nylon and all the fibers as well, but a much larger build volume, up to 330, 250, and 200 millimeters. Additionally, on the Mark X, we start to bring in some in-process inspection technology using a laser micrometer. I'll talk about that in a bit more detail as we continue through the presentation. And the interesting part about our printers is that they all are upgradable. And what this means is that you can really start with any Markforged printer you'd like. And if you decide that you'd like to add functionality and move up the line, you can do so after your purchase. This is kind of unique in the 3D printing space. We're showing the US pricing here. The Onyx One is $3,499, but if you decided that you wanted to step up to the Onyx Pro after purchasing it, for another $3,500 plus install fee, you can upgrade that Onyx One to the Onyx Pro and enable it to print continuous fiberglass. And if you have the Onyx Pro and you want to move up to the Mark II with all of the continuous materials, for $8,000, you can send that back to us. And we will turn it around and send it back to you. So at any point in this lineup, as you step up the line, you're able to sort of trade your printer back in or get it upgraded to enable more functionality. And there's even an upgrade path for the Mark X from the Mark II if you're interested. So let's talk a little bit more about the Onyx One. We designed this to be sort of every engineer's first printer. It's the only desktop printer that was designed from the ground up for carbon, which gives you twice the strength and stiffness of pure plastic. This is just a workhorse of reliability. This is one of our most repeatable printers that we have. We've been running these things in 20s of units in our production facility, making sample parts downstairs for 6 months. And these things just work. You get the parts that you expect every time. You know, they're really great printers to get started with when you're looking for sort of like accurate, high quality parts. And the thing about Markforged, the reason their parts look so great and so differentiated is that we design and develop each one of the technologies in-house. So that is to say that we make our own material, the Onyx material in-house. We develop the hardware of the printers themselves in-house. And then we work with the software team in-house to make the right software to lay that material down into the right shape to make your part. So sort of by owning the entire process flow to get to accurate, reliable, repeatable part, we're able to get a much better result than some of the other printers you may have seen in this price range. The Onyx Pro is Onyx printing, but you get that second print head for continuous fiberglass, so now you can start to really reinforce your parts. That makes them about 5 times as strong as some of the base plastics. This is an easy field upgrade. They'll come out and do it on site if you own the Onyx One. It's got the 100 micron layer resolution, and here's where you can really start to replace machined parts. If you're thinking about a manufacturing application, for example, where you've been to date using aluminum, CNC'd aluminum to make jigs, jaws, and fixtures, now you can get a part that's starting to approach that strength, but you can get it the next day and for about 1/10 the cost of that CNC machining process. So you have a sort of workhorse machine on your desk that's pumping out custom fixtures for you day in and day out, and of course all those other great applications Cynthia talked about. Let's spend just a second talking about software. Our software application is called Eiger. It's an intelligent cloud-based application that actually runs right in your Chrome browser. You slice, store, and organize your parts there. It's got really great administrative controls, so if you have more than one printer in your organization, you can sort of monitor all of them and their usage. You're able to, after you upload your STL, go in on a layer-by-layer basis and control all sorts of aspects of the part, specifically routing your fiber throughout the part, the amount that you put in, and the orientation and the volume. You can create sandwich panels, sort of a large degree of flexibility to reinforce the part to meet the strength needs of your applications while minimizing print time and material usage. And we also offer, this is very cloud-based from the beginning, but we also offer a local storage version if your organization has some restrictions around ability to upload parts into the cloud. You can store them locally, and there's an on-premise software option as well. And we'll get into a bit more detail a little bit later on, showing you some of the cool features of the Eiger software as we talk about the laser. So I'm going to turn it over to Cynthia here. She'll tell us a couple of customer stories about how some of our parts have been used in the field.
Here's a couple of customer stories about the Onyx material being used out in the field. And one of them is Dixon Valve, which is industrial automation equipment. They have a large robotic manufacturing facility, and they are printing with our Onyx material for their robotic arm end effectors and grippers, as well as other components within their production facility. This has been a great benefit to them because previous to using Markforged, they had to get these grippers CNC machined, and with the Onyx material, it has dimensional stability. It has the ability to print different sizes and shapes very, very quickly. And they've been looking at, just the cost comparison now that they do have the Markforged printer in-house. It takes about a little over 9 hours to print a set of grips. It costs $9.06 versus looking at outsourcing to get it machined with CNC mill, $290, and then 72 hours plus the wait time and the ship time. So you can see, just the comment and statement from the customer, the stability, as well as the just ability to survive their manufacturing department with our materials has been a big, big help to them. Another customer story, we've got Media Blackout. They're in actual end-use applications using our Onyx material for portable TV camera and electronics. They've got continuous carbon fiber in their parts, Their option was these parts were, difficult to machine or create in other, in other ways. But they did compare cost of printing this versus getting it done outsourced in the service bureau, and the turnaround time and ability to create these for end use in-house has been very beneficial to them as well. So back to John, this is going into the rest of the product lineup, Mark II as well as Mark X.
Okay, so the Mark II is sort of is the most popular printer we make, and that's because it's the printer where you start printing with carbon fiber, and that gives you the ability to maximize the strength of your parts. It has the 320 by 132 by 154 build area, 100 micron layer resolution, and it's really our workhorse. Most customers start here when they start with our printers because they want access to all of those fiber reinforcing materials. And I guess it really depends on your application where you start, but again, any printer can be upgraded, so start where you like and move up the line. And then finally, at the top of the line, the Mark X. This is where strength, quality, and surface finish all come together without compromise. This more than doubles the print volume of the Mark II. You get all those benefits of strong, lightweight parts in much larger formats and all of the unique materials. And then quality control, which we're going to go into a bit more detail on, but you get a print, because we have in-process inspection, you can print exactly as you design the part to be printed and actually stop in the middle of the print process to make sure that that's the case. We've reworked the entire print chassis here to make the build precision much higher. You've got 50 micron layer resolution, which brings you down to these sort of beautiful sheen finishes on the surface of the parts. So your parts actually get nicer, bigger, and more precise with the X. Let's go through some of those details around closing the loop from the design process to what you actually get out the print side. We added a laser micrometer to the X. It's on the print head. It scans the print while you're printing so that you get a precise dimensional inspection. You can currently add at any layer a scan, go in and measure or compare it to your design. After 3 or 4 layers of printing, decide if it's what you wanted or not, scrape it off the bed. If it's not, and reprint. We're working on software that will start to automate that process, allowing you to sort of put in some dimensional tolerances on these parts. And eventually we're going to drive actually live sort of in-process inspection that makes sure you're getting the part you want. And these will be software upgrades coming over time. The scan is accurate to 1 micrometer in the Z. It's actually 45 micrometers in XY, but we oversample so you get an incredibly accurate picture of the part. We'll walk you through what some of those look like. So this is a turbine housing. You're looking at sort of the Eiger 3D parts view of the turbine housing here. And we put in a couple scan layers. You can see those layers represented in the 3D view. And you see laser scans on the bottom here. You can sort of quickly select one of those in the 2D view. And here's a actual scan that we took of a part that we printed. You can see the detail here, the walls or the outer edge there, the incredibly accurate view of the infill, and then the support material, which was inside of this part, is also drawn accurately here. And this is the quality of scan you get of your part as you're printing it. And then, of course, just having a nice picture of your part is not enough. You want to be able to do some dimensioning. So here's a video that's going to show the circle tool. You can draw boxes, measure lines, and circles. Let me see if I can get that to play. Not sure. Okay, there we go. So we'll show you a circle dimension. With the circle tool, you zoom in and pick 3 points, and you'll get the dimensions of your circle. You can see 35.021 it looked like. I flashed there pretty quickly, but you can tell right away if it's in tolerance to what you need or not. And over time, we're going to make it more and more accessible for you to sort of have those happen automatically while you print. Today, you put a scan in a pause layer. It'll send you an email when it's done. You can check from any Chrome browser to see if it meets your needs or not. If not, scrape the part and start printing a better one right away, saving you a lot of time and material cost. Okay, let's try and get to the next slide. Of course, you use the laser for other things as well. Now we make it very easy to level the bed. We'll do a scan of the entire bed and model it in 3 dimensions, and then we'll hover over the 3 thumb screws we use to sort of level the plane of the bed. We'll automatically adjust the Z-axis to sort of best fit the topology as well. It's a really quick adjustment. The laser just kind of parks over the screw. You turn it left and right until you're in the green, and then you're done. Okay. This is just an example of the resolution you get with the 50 microns layer height on the X. You're starting to approach sort of SLA precision and beauty. You can see on the right-hand side here how smooth the surface finish on the part is. This is printed at a very shallow angle to sort of give you a worst-case surface finish. And at these shallow angles, you start to really see step heights when you're at the 100-micron layer height and above. Okay. So back to the sort of lineup side, I think we'll park it here and open it to questions. Please feel free to type these in, and we'll field them verbally. I see we have a question. Can you upgrade from the Mark II to the Mark X? Yes, you can. You can trade in your Mark II for a Mark X, and I think we're actually still running a customer appreciation offer for early customers of our product. Cynthia, do you want to?
Yes, if you currently have a Mark II, come and talk to us. We're running through March 31st a virtual trade-up appreciation offer for those of you who have had a Mark II and are looking to acquire a Mark X. It's a great offer. You actually keep your Mark II and receive a Mark X for the discounted cost of what you paid for your Mark II. So that's for existing customers who have already owned a Mark II. Otherwise, if there is an easy trade-up program for new customers as well. So we're trying to make the lineup, very modular and upgradable.
The way to think about it is that at any time you can recoup most of the value of the printer that you own in a trade-up. It'll never be cheaper than if you just purchased the highest product in the line to start with. You'll always have a little bit of expense there, but we try and make it as minimum as possible to encourage everyone to improve their experience over time and to step up the line when they're ready or when their application requires it. Okay, let's see. Here's another question. Is it necessary for a client to be in warranty to upgrade? So the answer is no, but the upgrade process will require for instance, if you're moving between the Onyx One and the Onyx Pro, you'll need to have your machine functioning. So the person who comes out to do your upgrade will check it, make sure that it's working. And if there's any broken parts, you'll have to, if you're out of warranty, pay for those to get it up to a functioning status. They'll then complete the upgrade, and as part of the upgrade, you'll be extending your warranty for an additional year post-upgrade. So there's a opportunity there along that upgrade path if you're out of warranty to get your product repaired if it needs repair, or otherwise just simply you'll be able to extend your warranty or restart it. Okay, let's see what we got here. Are there any Markforged printed parts as a component of the printer itself? Yeah, we do print some of the parts of our printer. In the Mark X, there's handles on the base, and in all of the printers, some of the holders for some of the internal electronics inside of the subassembly are also printed on the printer.
And I'll add to that a little bit and say we use our printed parts as tooling and fixtures in a lot of our own production as well. So you look at our manufacturing facility and where we create the fiber, there's a lot of printed parts within that process and across many of the different steps in our production.
Okay, where does the Mark X have its onboard camera? So if you're looking at the printer from the front, the onboard camera is in the top right-hand corner, pointed sort of down and into the build enclosure. And it's not modeled on the particular image of the Mark X here, but there is a camera on the Mark X, I guess, is part of this. You can go into Eiger while a print is running, click on the images from the camera and check in and see how the print's running. That's kind of a nice way for you to check that the part is being built like you expected, even though you're maybe not on site with the printer. Okay, nylon is said to absorb water. How is Onyx affected by water? Is it stable enough for marine outdoor applications? So there's kind of two ways to think about this. On the pre-printing side, both nylon and onyx need to be kept dry, because if you get moisture into the material when it's extruded through the hot print head, it can cause bubbles in the material that make the part quality go downhill pretty fast. And then you can think about sort of post-use of the parts. Onyx is similar to nylon, but the chopped carbon that's added to it makes it a little bit more stable and less likely to warp in the presence of water. And we have actually a lot of people using our parts in marine applications, but they're typically reinforced by carbon fiber or maybe continuous fiberglass, which helps maintain the structural integrity of the part as it's exposed to moisture, because as moisture is absorbed by both nylon and onyx itself, the material will start to soften a little bit. So reinforcing it with one of the continuous fibers sort of mitigates that complication.
We have parts on ships, as well as used in surfboards and water skis and other applications, and they've been pretty well tested. So if you're interested in more information, just get back to us after the webcast on that.
Okay, I see. Is it a heated bed oven? The answer is no. I can see that the person asking this question has also stated that many of the competition pitched the heated bed and print envelope as important parts of the printer. We've actually formulated our materials to what you're really trying to do with that heat is get the part to really stick down to the print bed accurately. We've formulated our materials to do that at room temperatures. The parts stick incredibly well to the print beds. And so that's kind of like one of the benefits of Markforged, which is that you don't need to keep it in a heated environment. There's some other benefits you get from that, which is you can pause your print in the middle of printing. You can actually remove the build plate from the printer. You can insert metal parts into it as long as they're below the level of the top layer. So if you wanted to put like a screw inside of your part for whatever reason, you can do so. And then the print beds have kinematic couplings, so you can very accurately drop those print beds right back into the printer and hit resume and just keep on printing. So that's some of the advantages you get from the ability to print at room temperature. Okay, let's see. Got a few technical questions. We'll try and answer those as one-offs directly, in some cases referring people to the material data sheets. Let's see, I understand it's not ideal for structural parts, but can the printer utilize other filaments as well as nylon-based ones? On the plastic side today, we only support the nylon-based materials because those are what we've built in-house and what we do all of our design and testing around, and the ones we feel incredibly confident about the part quality with. Of course, we're always working on stuff on the roadmap, but today it's nylon only. What is the price of the Mark X machine? The MSRP in US dollars is $69,000. And you can find more information about that on our website. Okay, let's see, we're looking through the questions. Are any of your materials sterilizable for surgical applications? They can be sterilized, but they're not FDA compliant. So that's maybe something we can work on in the future. We wouldn't recommend them for use inside of people or anything like that. But yeah, you can sterilize the nylon and the onyx if you need to. Let's see. Are future upgrades coming that will print more volume per minute? That's a good question. We're releasing and we've already announced a thing we call turbo mode, which depending on your part shape and volume, can as much as double the print speed. We do this by printing the internal layers at different heights than the external layers. So you get like a very nice looking cosmetic exterior, just like normal, but the insides of the part print much faster. Okay, I would like to have access to the software so that I could evaluate filament placements. Yeah, you can go to our website and sign up for a 7-day trial. and play around with either yourself, upload your own parts, have fun. Oh, the trial period is too short to be useful. I see that addendum here. Please just submit a ticket to support and we'll extend your trial period for you. And yes, my intent is to make it longer so that you have the time you need to experiment as much as possible. Okay, so I think that mostly wraps up the questions. There's a few technical ones that we'll answer sort of offline. What's the greatest layer height allowable? I think we print 200.
Yeah, we print up to 200 microns. It's the greatest layer height. Yep.
All right, well, thank you everyone for attending. If you have extra questions, feel free to contact us through the website. You can easily send us questions, request demonstrations, ask for sample parts. We're happy to share them. The best way to really be convinced about the value of the printer is to get hands-on with some of the parts, because that's the way you really can connect to the strength of the materials once they're reinforced.
And your local reseller will be able to show you demos of the printer and help share what kind of parts you might be able to print on our printers. So thank you very much for your time today. We will share these slides with you shortly after the fact, and come back if you have any other questions. Thanks so much.